Hello, exceptional students of Mrs. Whitney's. So today we're going to talk about the percent of change. We're going to talk about the percent of increase and the percent of decrease and percent of error. So percent of change is just the percent that some quantity changes from the original amount and goes to a new amount. And it's like saying, something increased by 50% or 100%. If it's 100%, it doubled. So there's a way to calculate that. And it turns out that you just have to take you can separate it to be the percent of increase and the percent of decrease, but really it's the amount of change, which means you take the larger number, subtract the smaller number, and you divide it by the original amount. You can memorize these two formulas, but it really doesn't make sense. It makes more sense to think about it in context. So, for instance, like this. If the table shows the number of hours you spent online last weekend, what is the percent of change in your online time from Saturday to Sunday? So if we know that the percent of change, is equal to, the difference divided by the original. Okay, so if we're talking about the percent of change from Saturday to Sunday, we're talking about going from this many hours online to going to that many hours online. So first of all, we know that the percent of change is an increase because you start at 2 and you go to 4. So we know that this is an increase. Then we take the difference between the two numbers. So we take 4 and 5/10 and we subtract 2 from it. And then we divide by the original. And the original is where we started. The original would be 2. Now remember, order of operations says that before I divide, I have to figure out what the subtraction is. So we know that 4 and 5/10 subtract 2 is 2, and 5 and 5/10 divided by 2, and that is going to give me, let's handy dandy calculator. That is 2 and 5/10 divided by 2, which is 1 and 25/100ths. Now it's tempting to say that it's 1%, but think about that. Doesn't really make sense, does it? Because you more than doubled. You started at 2 and you went to 4.5 hours. So remember, this is not yet a percentage. So we have to take this 1 and 25/100ths, and we're going to multiply it by 100 because that's how we convert a decimal to a percentage, and that will give us 125%. And that's what the percent of change is. All right, let's look at percent of decrease. So this is a softball player's home runs. What is the percent of change from 2012 to 2013? We know that at 2012, they hit 28 home runs. And we know that at 2013, we hit 20 home runs. So our percent of change is going down. So we know that it is the difference. We take the larger number and we subtract the smaller number. And in this case, we started out at 28, so that's what we divide by, 28. So this ends up being 28 minus 20, that's 8 divided by 28. And so if we divide 8 and 28, that gives me 0 and 29/100ths. And we need to multiply that by 100 to give us 29%. So we decreased in home runs by 29%. Okay, the last thing we're going to look at is percent of error. Percent of error is the amount of error divided by the actual amount. So this says that if I estimate the length of my classroom is 16 feet and the actual length is 21 feet, we are going to say that, again, we're finding the difference. So it's the difference divided by the actual. And since percentages are always positive, we take the larger number we subtract the smaller number, and then we divide by the actual amount. So I estimated it at 16 feet, but the actual length is 21 feet, so I divide by 21. So this gives me 21 subtract 16. That is 5 divided by 21. So 5 divided by 21 gives me 24 hundredths. And again, I'm going to multiply 24 hundredths by 100 to convert it to a percentage, and I get 24%. So thanks for watching. So finding the new or old amount using a percentage. So we did the previous examples were all about percent of increase or percent of decrease. Well, what if you knew where you started from and that you're decreasing by 25%? So what is the new amount? So there's a way to look at this that kind of helps you sort of figure this out. We're, of course, going to use a proportion to be able to solve this. So if we think about this using those bars that I had you do. So if you have 0 and 100% is everything, and 0 and 12 is where we started. So that's 100% of whatever we're decreasing. So 12 would go here. And we're going to decrease by 25%, which means that there's 25% of the 12 that we're getting rid of. We don't want it anymore. We want to know what this new amount is right here. In order to find this, the easiest way is to find out what percentage of the whole am I looking for. And if I'm not going to get the 25%, then I'm really just interested in finding out what 75% of the total amount is. So when I do the proportion, we have the 100%. Let me change colors here. 100% is 12. So it's always the percent over 100, and the 12 goes with it. We don't know what the new amount is. So that's our unknown. But we do know that it's 75% of the 12 that we're looking for. So it is 75% is the part, and that's the part we're looking for. 100% is the whole, which is the 12. Cross multiply, and 75 times 12 is 900. So 900 equals 100x. Divide both sides by 100, and the new amount is equal to 9. Well, what if you have an increase? Well, the same thing. Start by thinking about 0 and 100%. And 100% is at 9 that we're increasing. Well, if we're increasing, it's more than 100%. So if we're increasing it by 30, we add 100 to 30 to get the 130%. And the unknown is this one right there. So again, the proportion falls out. The percent over 100 is 130. 100 is the, so is a percent over 100. 100% of the item is 9. That was the whole amount, and the new is here. So again, we cross multiply, we get 100x is equal to 9 times 130, which is 1,170. Divide both sides by 100. So if you decrease 9 by 30%, you end up with 11 7/10. Oh, by the way, I'll just go back over to here. So we found the 75% by saying 100 subtract 25 is equal to 75. So going back to this one down here, if you have a number decreased by 40%, same thing as up here. Oh, actually, this is a little bit different. So a number decreased by 40%. So we don't know what that number is. That's our unknown. But we know that that was the 100% we started with. And we're decreasing it by 40%. And the new amount is 38 4/10. And we know that if we take that 40% off, it's 100 minus the 40 gives me 60. So that is 60. So again, the proportion kind of just falls out of all of that. It is 60% over 100. And we know that that's the part. So that would be 38 and 4/10 and x. Now if I cross multiply, I get 60x is equal to, let's see here, 3,840. Now if we divide that by 60, we end up with, sorry, I had to grab my calculator. So if we divide those, we end up with x is equal to 64. So thanks for watching.